Hi, great friends. Welcome to Spark Genius Academy with Polite. As promised, I said that on lesson 4, we're going to work on one more example on the K method before we start with exponential equation. So let's get to it. So now let's say that we need to simplify the following. So I have 2 to the power 2x, and this is minus 1 over, we have 2 to the power x plus 1. Remember what we discussed on the previous lesson? We said that if we see the x and the 2 to the power x, and these two guys, they have the same base. This tells you that this is the K method. So look at this. I have the 2 to the power x and the x with the same base. So now we can see that this is the K method. What do we do first? We change that one. Everything should be to the power x. So we need to write the 2 to the power x, the 2 to the power 2x as 2 to the power x, then take the 2 out the brackets. Then we have minus 1, and this is divided by 2 to the x plus 1. Ladies and gents, when you have it like this, you can just let your k. Now is the time to let k to be what? To let k to be equals to 2 to the power x. Meaning that on your equation, where there's 2 to the power x, you can put k. So this will be k squared minus 1 over k plus 1. Okay, let's continue working on this. I can say that we are having so much fun because I'm enjoying doing this. This tells me that you are also enjoying watching the lesson on your side, because this is easy, man. So now let's work on the top part. So the top part can be factorized. Remember, this is the difference of squares. Because 1 is a perfect square, we can open the brackets and then k on both sides. Then let me quickly bring it up here. Remember, we have k squared minus 1, which is divided by k plus 1. So when you have it like this, it's k squared minus 1. So you put k on both sides and 1 on both sides. One bracket should be positive, the other should be negative. Then everything is divided by that k plus 1. And then look at this. We have the common terms. We can cancel those two. And what do we have now? We only left with k minus 1. Please do not leave your answer as k minus 1. Remember, where there's k, we need to substitute back that 2 to the power x. So the answer is 2 to the power x minus 1. Wow, that was nice and easy. So please make sure that when you factorize the difference of squares, you open the bracket, you find the square root of 1. We know it's 1, you put it on both sides. One bracket should be positive, the other one should be negative. And that's it for this lesson now. I'm sorry, that's it for this example. But now let us talk about the exponential equation. Let's work on the exponential equation. Remember, that was a homework problem. So now we're going to dive into the exponential equations. Okay, so on the exponential equation, let's work on the first example. Let's say they want you to solve for x. So this one will work on most of the time. Remember, we're talking about an equation. So your expression, whatever that you have on the left hand side will be equated to something on the right hand side. So let's say we solve for x. So when we solve for x, the first one is given as 3x to the power 3 over 4. It equals to 24. Right. So first thing first, your aim in this problem is to isolate that value of x, is to isolate x. So how can we isolate x? We can isolate x by dividing both sides by 3 first, and then we'll be left with x to the power that 3 over 4, which will be equated to what? 24 divided by 3, that's 8. So I'm going to say this is 8. Right. So now I'm going to teach you guys how to get rid of the exponent. So now you take the x with the 3 over 4. Then I'm just going to equate this to 8. So to get rid of that exponent, because you are trying to find x, you multiply the exponent with the reciprocal of that 3 over 4. So we're going to multiply this by the reciprocal is 4 over 3, meaning vice versa. If it was 3 over 4, you multiply by 4 over 3. But remember, what you do on the left hand side, you also do on the right hand side. Remember, this is to the power 1. You have to multiply that 1 by what? By the 4 over 3. So now this 3 cancel, the 4 cancel, then what are we left with? With x only, which is what we were looking for. So x is equals to 8. Now let's change that 8 and write it as a prime factor. So it's going to be 2 to the power 3, which is to the power 4 over 3. Then now you can multiply your exponents. So you can multiply your exponents. When you multiply your exponent, I think you can see on your side that this 3 and that 3 will cancel, because it's like saying I have 3 times 4 over 3, the 3 cancels, and I'm left with 2 to the power 4. So this will be 2 to the power 4, which is just 16. So therefore we can conclude and say x is equals to 16. Right, I hope that was easy. That was very easy, né? I really hope so. So let's work on this one. That was the first example. Let's work on the second example. So on this one, let's say I have 2 to the power 3x minus 16, and this is equated to 0. How can we solve this? Let's isolate. Remember, this is 2 to the power 3x. So I'm just going to move the 16 to the other side. And the 16 will be positive. Why are we doing this? First thing first, you need to get one term on each side. Okay, get one term on each side. Then when you have that one term at each side, you need to write as the prime factorize of 16. We need to write as the prime of its base factors. So this will be 2 to the power 3x. It's equals to 16. It's 2 to the power 4. Right. Let's say something about this. What do you see on this equation? What do you see? This is what you need to ask yourself. I have the same base, different exponent, and remember, base are equal. We have the base are equal. So if the base are equal, what can we conclude? Therefore, the exponents will also be equal. The exponents are equal. Right, so we can just equate the exponent and say 3x and 4 are equal. Solve for x, divide both sides by that 3. What is x? X is 4 over 3. Guys, I hope you are having fun on your side, because hey, this is easy, né? This is easy. But now tell me, let's say that I need you to pause the lesson and think about how you can solve this one. How can we work on an equation like this one? 3 to the power 3x, and it's equated to negative 27. I need you to think about it. What can you do? Think about it, pause the lesson, think about it. Then let's see if you're going to work this thing out, same as me. Okay, so now I know that maybe you have a full page trying to work this thing out, but trust me, there's nothing you can do. The 3 to the power x, this guy here cannot be negative. Cannot be negative. So since it cannot be negative, so now we're going to say Since it's equated to a negative number, there's nothing we can do on this equation. This is equation, it's no solution. There's nothing you can do. So now why there's nothing we can do? Because okay, let me not confuse you, and that's it for this problem. There's nothing you can do. You can say no solution. No solution for x. Let's write it down. No solution for x. Okay, so let's keep on working on these exponential equations. Let's keep on working on them. Okay, so now the next problem that we need to focus on, let's say you have 25 to the power x, and let's say it's plus 1. This is multiplied by 5 to the power x, and this is equals to 125. How do we solve for x? Right, so we already have one term on each side, né? So we already have one term on each side. So what you can do from this, let's change the 25 to prime factors. So the 25, we know it's 5 squared, so this will be 5 squared, everything to the power x plus 1. This is multiplied by 5 to the power x, it's equals to 125. So now you can multiply out the bracket by the exponents. Multiply the exponents. This will give us 5 to the power 2x plus 2 multiplied by 5 to the x, which is equals to 125. So now what I'm going to do, I think it's best if we also change the 5, né? The 125. We know that you say 125 equals to, then you say shift fact, it will tell you that this as the prime of its factors is 5 to the power 3. So now all the bases are the same, and this side we are multiplying the same base. What do we do to the exponents? We add the exponents. So this will be 5 to the power 2x plus 2. We add the x, and this is equated to 5 to the power 3. So now we need to check if we have the like terms there. Yes, we do. The x and the 2x, we're going to add those two to get 5 to the power 3x. So this will be 5 to the power 3x, then plus 2 is equals to 5 to the power 3. So these are our steps. These are our steps. So now to move here on top, remember we have 5 to the power 3x plus 2. That is equated to 5 to the power 3. The bases are the same, and remember we said that if the bases are the same, the bases are equal, this tells you that the exponents are also equal. This is what I have so far. Let's isolate x. This is a linear equation. Let's work on that. The 2 goes to the other side to be negative. When the 2 goes to the other side to be negative, this will be 3 minus 2, which is 1. So the 3x will just be equals to 1. Divide both sides by 3. Therefore, the value of x, ladies and gents, is 1 over 3. And that's it for this problem. That's it for the for this problem. But now, what do you do if you are given a decimal form? How do you solve this type of a problem? Right, how do you solve this? Let's say we have 4 times 8 to the power 2x minus 1. And this is equated to, let's say I have this as 0.125, and this is to the power x minus 1. How do you solve this type of a problem? We need to write first, you write that 125 as a common fraction. So you just have to say 0.125 on your calculator to tell you that, hey, this is 1 over 8. So let's quickly change that common fraction. So this will be 8 to the power 2x minus 1. It's equals to, this is 1 over 8 x to the power minus 1. I don't want to explain a lot of things in one step. So this step was for changing the decimal. Let's move to the next step. The next step is to change everything to the prime of its vectors. So the 4, we can write it as what? The 4, we can write it as 2 to the power 2, close the bracket, The 8 is 2 to the power 3. Close the bracket, which is to the power 2x minus 1. We equate this to 1 over 8 is to the power 3. Then remember, everything inside the bracket is to the power x minus 1. Let's keep on moving. I think now that on this step, we have to first change what? I think, guys, so far you can see that I don't do a lot of steps. I mean, a lot of things in one step. So if this step is for writing the prime factors, I only focus on that because I don't want to be confused. So now on the next step is to change this fraction. That's what we're going to work on the next step. Let's work on that. So this will be 2 to the power 2, 2 to the power 3 to the power 2x minus 1. It's equals to, so now remember, there's a law of exponent that we discussed on our previous lesson that says if I have 1 over x to the n, this can be written as x to the power minus n. So everything on the denominator but the exponent is negative. So everything on the denominator but the exponent is negative. This is to the power x minus 1. So if you understand that part now, you know what we need to do. We need to multiply out the brackets. The exponent, this times this times that. So this will give us 2 to the power 2 multiplied by 2 to the power 3 times 2x, it's 6x. 3 times minus 1, it's minus 3. Equate this to 2 to the power minus 3 times x, it's minus 3x. Then I have minus 3 times 1 times minus 1, which will give us positive 3. Please multiply each term. When I say multiply each term, this times that and this times that. Multiply each term by that exponent. What do we have this side? The same base that we are multiplying. So we're just going to add the exponent. This is 2 plus 6x minus 3. It's equals to 2 minus 3x plus 3. So these two guys here are the like terms. These are the like terms, guys. No need to rush. Oskaja, just take your time. Can you see that each and every step I only solve one problem? You can't just don't solve all your problems at once. Don't do that. Solve them one by one. So now I need to add the like terms on this term. So this will be 2 to the power 2 minus 3, it's minus 1. 2 minus 3, it's minus 1. Then I'm going to have 6x minus 1, it's equals to 2 to the power negative 3x plus 3. So now look at what I have. I have 2 to the power 6x minus 1. We equate this to what? 2 to the power negative 3x plus 3. The base are the same. What do we do to the exponents? The base are equal. This tells us that the exponents are also equal. Right. So when you have it like this, group the like terms. Now the one with the variable x, bring them on one side. So the 3x will move to this side to be positive. So this gives us 6x plus 3x, which is 9x. It's equals to, the 1 will go to the other side to be positive, which is 3 plus 1 is 4. So this is 4. Divide both sides by 9. By 9, what is your x? It's just 4 over 9. So this is your final answer. This is your final answer. Okay, so and that's it for this lesson. I'm looking forward, guys, to see you on our last lesson of laws of exponents. So the last lesson of laws of exponents, we just gonna only work on this one and some of the questions from past papers. So the first question that we're going to discuss before we do the past paper on laws of exponents is this one. So this is 5 multiplied by 3 to the power 2x plus 6. Then we minus 5. This is equated to 0. Ladies and gents, I need you to work on this problem, have your solution ready for our next lesson. And that's it for this lesson. And if this is your first time watching the lesson, please make sure that you hit the subscription button so that you don't miss our next lesson. Trust me, you don't want to miss our next lesson. Thank you guys for watching. This is where we stop for lesson number 4.